his title, Machine Frames Made of Wood. I was intrigued by that title when I saw the programme and wondered what on earth it was going to be about. I had some reservations. Now, what Roland says, that wood is used in lifts, and they're used to, now they could be used more to reduce energy consumption and environmental impact, and thus produce better lifts. It's barely used these days in lifts, and but the number of high-rise buildings made of wood continues to increase, and it only seems logical, he says, to consider using wood for lift construction as well. At present, the increasing number of high-rise buildings in the world are being made of wood, and among them there are two types. Of the two types that I'm showing on this slide, the first is a wooden construction built around a concrete core, that's the left-hand one, and the second type, which satisfies purists even more, who prefer buildings completely constructed of wood, is this one here, which is 85.4 metres high, and is officially the world's tallest building. There's one there which is proposed to be placed in London. It's a building proposed by researchers from Cambridge University and PLP architects, and this is going to be a 300 metre high wooden building in London. Now, the paper that Roland will be presenting is not talking about wooden buildings, but talking about using wood within buildings. And he says that the materials for wood needs some considerations, for instance, on strength. There is an EN standard 1995, Design of Timber Structures, Common Rules and Rules for Buildings, which debate the different characteristics of wood and the strength classes of wood. And you can see these hieroglyphics, C14, C50, D30 to D70 up there, which didn't mean anything to me till I looked into them. And basically, if you look at that table, you can get bulk densities of wood from 410 to 520 kilograms per metre cubed in the range C35 to C50. That's the last four on the top there of the poplar and softwood species. But if you move up to the hardwood species of woods, you can get between 740 and 870 kilograms per metre cubed, which is considerable improvement. And this means that really only hardwood species come into consideration if you're building a building of wood in terms of the requirements for strength. Solid timber has a load dependence on the grain of the wood, and the strength decreases with moisture content, which is a problem. And he cites an example that if you change the moisture content of wood from 12 to 20%, it reduces the strength by 26%. So an 8% change in moisture content in wood reduces the strength by 26%. And the dimensions change as well. To overcome that on a pure piece of wood, plywood was invented 150 years ago, and that's with the interlaying cross grains that you got in it, was the first manifestation of these laminated wood products. And as a result of that, higher strength values were produced, the swelling problem and the shrinkage reduced, and this slide shows a number of different laminated type products that you can get. Glulam, the cross-laminated CLT, the LVLs, the laminated veneer lumber. And they come under different names. This Bobach Q is a name of a particular laminated wood. Quite funnily for me, and serendipitously, the first one, Glulam, I've come across that before, because the People's Hall in Sedbergh, which was built in 1956, is constructed of glulam beams, pre-stressed, and the weight of the roof on top of those pre-stressed glulam beams keeps the roof and the beams in coordinated form, such that we have a nice open space. And they're still there, they're not delaminating or anything. We actually have a leaking roof, and I've got a project on at the moment to replace the slates on the roof. And clearly I've got to do that carefully, because I'll take them all off, the whole thing will pin, and we won't have a People's Hall. So glulam was familiar to me, and I'm quite pleased to be presenting this paper where I can see some relationships with wood. There are some special aspects to consider when designing with timber. The large influence is the moisture content, and this graph on the left-hand side shows you what happens as the moisture content increases. We've got German words all over it, but I think you can probably understand what that means. And it deals with the service classes, which are in this lower table. Now, wood deforms more than steel when it's under constant load. I mean, my People's Hall is kind of deformed, because we took the beams, put a weight on them, and deformed it into a pre-stressed situation, except that we had the beams pre-stressed, and then we took the stress off by putting the roof on. So there's a higher deflection of bending under load. And these considerations have to be taken into account in dealing with low duration classes when dealing with wooden structures. Now, there are some other special aspects to consider when designing with wood. Fire resistance. Wood is flammable. It does withstand fire for a surprisingly long time by the carbonisation of the surface and so on. And we make fire doors of wood, don't we? There's problems of gluing the things together with formaldehyde, other adhesives as well. Some of these are not really very nice for us humans. And then there's pests. Pests include fungi, insects, bacteria, which can cause difficulties with wood deterioration. Now, Roland is proposing making machine frames out of wood, and he shows two pictures. The left-hand side is made with this beech material, and it's completely made of wood. He somewhat abandoned that idea in the difficulty of constructing it by a second version on the right, which has got some metal. The some metal being mainly keeping the thing together by bolting it together rather than using wooden dowels and glues and things. The second version was preferred because it could be manufactured better than the first version. The design that's up there, surprisingly, and I can't actually work out the size of the thing, all I can see is these paving slabs in here, and experience of laying paving slabs would suggest that this is something like a metre long slab, and so that gives you an idea of the size. That particular version that you see there is for a 450 kilogram lift, running at 1 metre a second with one-to-one direct reeving, and the weight of the motor that is on the thing is 200 kilograms, and the machine frame weighs 100 kilograms. Of the construction, steel parts contribute 40 kilograms, and the wood contributes 60 kilograms. He makes the point that the low weight, he considers that to be a low weight, facilitates transport on the building site and in installation. And there's an important point, perhaps, and maybe the key as to why this particular session is with the other two erudite presentations on vibration, is that wood, unlike steel, has a lower tendency to vibrate, and so that gives you an advantage to that. There's some further information that he puts up here, the contribution towards reducing the environmental burden. And he's taken the Otis Gen 2 Stream Environmental Product Declaration as his example. And it talks about things I don't particularly understand, U1s and D4s, which are global warming potential and adiabatic depletion potentials. All seem to be very long-winded words or something, but basically he's saying that it is possible to improve the environmental impact because of using wood. Now, when I first saw this paper, and I don't know whether this one's going to work, but I'm sure Sam will help me. Do I just go like that or something? Worried me a little bit. So we have the Tower Inferno, and I'm thinking wood all over the place in a building. Not really a terribly good idea, perhaps. So I had a look at, is wood allowed to be used in lift construction? And in EN 8120 at 5.4.4 is the only bit I can find which talks about flammability and things catching fire in lifts. Traditionally, 100 years ago, most of the construction of a lift would be wood. The cabins were wood, even the rails were wood. I'm sure some of the older folk can remember the wooden round rails that we used to have on the lift. Everything, more or less everything was made of wood, held together with bits of metal, just as he described. And so it's not so much of a problem, perhaps, to wonder whether we're going to be safe from things catching fire. EN 8120 is only talking about the flammability within the car, and that's the only section I can find. The supporting structure of the car body shall be made of non-flammable materials, so we won't make the cars out of wood. The materials selected for the floor have to meet the requirements of that EN 13501-1, and it then lists the reactions for the flooring, wall and ceiling with those letters and numbers, and it indicates that the paint finishes and laminates are 1/3 of a millimetre, that's 300 microns. If you consider your hair is about 2,000 microns, depending on various other things, then that's a very small amount of material that you're allowed to put inside a lift car and stop it catching fire. But what do those hieroglyphics mean, Nick? Those there, CFL-S2, C-S2D1, C-S2D0. Do you know what they mean?
No, I think you need to go to 1 through 1-1.
Well, I thought we did, and here we are. We haven't rehearsed this. I just felt that somebody like Nick ought to actually know EN 81-20 right the way through, and I don't think many of you actually have ever looked at this particular clause, have you? You cherry pick what you want to look at, and I had to look at it. I thought, oh, it catches fire in the lift. So that standard tells us what those things mean. And anybody designing a car should take note of them. Do you take note of them when you design a car? You plaster laminates all over the wall, you've gone past 0.3 of a millimetre, haven't you? So you've got problems. And you've got 7 grades of combustible classification, A1 to F. You've got smoke propagation, and you've got flaming droplets. And if you were, remember I talked about being able to have transparency, reproducibility, repeatability. I must say for a standard where it says S1 is a little or no smoke, S2 is quite a lot of smoke, S3 is substantial smoke. If I did that in the British standard, I'd have somebody called, what's her name, coming along and say, you can't verify that, can you? And look at it. Droplets, none, some, and quite a lot. That's the European standard. But we do get the message, don't we? We get the message that we ought to try and make the situation right inside the car. Do you also note that it's 10 minutes of exposure? So that sounds to me that if a car catches fire, you've got 10 minutes before you're dead. Which is quite serious, so please don't keep laminating cars with more than 0.3 of a millimetre. So there's the answers, Nick, that you were going to give me, if you didn't know to say so. Anyway, congratulations to Roland for producing this paper and allowing me to present it.